Well, hello everyone, and welcome to a series of videos describing the construction and use of a cave intrusion detector. The purpose of this device is to detect light, however faint it may be, inside a cave. By doing so, we get to understand when caves are being visited by humans, and especially caves which are officially closed to human traffic. This detector needs to go into the dark zone of a cave, into the far backest reaches, completely out of sight of any light from the entrance. If any light at all shows up in that part of the cave, then we have to assume that there's a human going through, because nothing else that goes there is going to bring any light with it. The cave light detector looks like, when finished, looks like this. It consists of an Arduino Pro Mini microcontroller. There is a real-time clock. There is a micro SD card reader, and kind of hiding right there is the light detector itself. All of that is built onto a circuit board and is powered by one or two 18650 lithium-ion batteries. It's in this peanut butter jar to protect it from the humidity and other things that go on in a cave. If we pull this out, I can point out the pieces of it a little bit easier. The first is the battery holder for an 18650 lithium-ion rechargeable battery. Most of these that I build use two batteries wired in parallel. This particular one is my test case, and so it only needs one battery. It's not going to live in the cave for any length of time. With two batteries, the life in the cave should be in the range of 6 to 7 months. On the circuit board, I pointed out earlier, this is the Arduino Pro Mini microcontroller. These can be sourced off of Amazon in prices ranging up to around $7 or $8 a piece. You want to make sure you get the 8 megahertz 3.3 volt version. This is a real-time clock. I'll talk more about it in a moment. This card is the interface for the micro SD memory card. The data about the intrusions that are detected by this device are stored on the memory card. This is the actual light detector. The detector is a very small piece right here at the end of the knife. The rest of this is just supporting circuitry. The other items on this board are an LED, which does some activity indication. There is a transistor, which turns the power off to the memory card interface when it's not being used. And then you have a current limiting resistor right here, which goes with the LED. The board that this is built on is called a Adafruit Permaproto half-size breadboard. I'll show you one that's not been built in a moment. And there's wiring on both the front and the back side. As I go through this tutorial, I will be demonstrating how to do the wiring, how to prepare each of the various pieces, and solder it all together. So with that, let's go into the individual pieces in more detail. The most important piece of this is the Arduino Pro Mini microcontroller. This is an unassembled Pro Mini. As you can see by looking at the size of my fingers, it is not a very big device. These devices are quite common. They're fairly easy to program and reasonably powerful. It does everything that needs to be done for this project. These come in two versions. There is a 3.3 volt and a 5 volt. The 3.3 volt version runs at 8 megahertz. The 5 volt version runs at 16 megahertz. Either will work for this project. However, the 3.3 volt version will run longer on the battery. As the battery is used up, as its power is consumed, the voltage gets lower. And the 3.3 volt version will continue running at lower voltages than the 5 volt version. So make sure you get the 3.3 volt version of this. I have found some vendors on Amazon who do not have good inventory control. When you order the 3.3 volt version, you may get 3.3 or 5 volt, you don't know. It's a little bit difficult to tell which version is which. You need a microscope almost to read the inscriptions. The voltage regulator, which is this piece, has a number on it, which can be cross-referenced to other part numbers to find out if it is a 5 volt or a 3.3 volt regulator. The clock crystal, this piece, also has a stamping on it that will tell you if it's an 8 megahertz or a 16 megahertz part. And in the worst case, you can hook up about a 6 or 7 volt power source to the raw and ground connections. That's these two connections here. And then measure the voltage output at VCC. That will tell you what the voltage output of the regulator is. And by knowing the voltage output of the regulator, you know whether it's a 3.3 or a 5 volt part. The second part is a real-time clock. The real-time clock is a DS3231. These also can be ordered from Amazon. They're quite cheap. They're $6 or $7. We'll buy you 5 of them. These have a slot in them for a CR2032 lithium coin battery. The coin battery keeps it going when it's unpowered. The purpose for this is to keep track of the time so that when an intrusion event happens, the program will read the time off the clock and use that when it writes the data to the memory card. The next item is the light detector. This is a TSL2591. These can be had from Amazon, but they're fairly expensive. If you go to Adafruit, you can get them for much less. This is version 2 of the light detector. It looks slightly different from version 1. Going back to my prototype board, you can see that version 1, this piece, is laid out somewhat differently than version 2. They are functionally identical and the software is the same for both. Because of the difference in size, it changes the way the board layout has to work. And so the board that I'm going to wind up building will have the memory card interface on the back side of the board instead of on the front side of the board. Other light detectors may work. This is the one for which I have wrote the program. This is extremely sensitive and has a very wide range of sensitivities. It's able to sense light as low as about 1/1,000,000th of a lux, all the way up to something like 88,000 lux, which is brighter than full sunlight. The next piece is the interface for the memory card. This chip, this board, handles a micro SD memory card. These come in bunches of flavors. They can be had off of Amazon. They're again very cheap. The big thing to be sure of is that you know that you can handle an SPI, a software programmable interface. It will, if it can handle that, it has an MOSI and an MISO pin on it, in addition to clock, chip select, voltage, and ground. It's also useful to look for one that's labeled 3V3, because those are the 3 volt parts. A 5 volt part would probably work, but will have a voltage regulator on it that consumes somewhat more current than the 3.3 volt part. The next piece is a micro SD card. Any card will do, however, it must be less than 4 gigabytes. The data stored by this program is very minimal. In fact, 1K or 2K bytes of storage would be sufficient. In 6 months, you may only get a half a dozen detections, and each detection is just one short line of text. So this is a 512 megabyte card. These are about the smallest that are still reasonably available. The major limitation is 4 gigabytes, as I said, and the reason for that is that the interface code which runs on the Arduino cannot handle file systems greater than 4 gigabytes. The next piece is the board on which it is built. This is an Adafruit Perma-Proto half-size breadboard. These can be had on Amazon, but they're less expensive by quite a bit if you go to Adafruit and buy them. recommend that you also buy some of these breadboards. Notice that the breadboard and the permaproto are laid out exactly the same. I recommend that you build one light detector on a breadboard just to make sure that it works, just so you can see how the wiring goes together. And that also gives you an experimental device that you can change out different light detectors, different memory cards, different real-time clocks as needed. And then there are some small items that go with this. The first is a resistor. This resistor is a current limiting resistor that goes in series with the LED that I'll come up with in a moment. And this particular resistor is 3.9K, quarter watt. The exact value is not critical. Anything over probably 3K up to around 7 or 8K ohms will work. The critical thing is that it needs to knock down the voltage so that the Arduino does not overpower the LED. And I found that a 3.9K ohm resistor works very well for that. The LED is also not critical, and it really is not even needed for the project to work, but it does provide some useful feedback as to what's going on. I wrote the program in such a way that it will turn on the LED when it is writing data to the memory card. It gives you a visual feedback that things are actually happening. The exact LED is not critical. This happens to be a 2-volt, 20 milliamp LED that I happen to have a bag of sitting around. You can buy these things off of Amazon in many different flavors. The key point here is that the LED and the resistor are kind of a matched set. They need to go together to accommodate about a 4-volt potential across the two of them in series. The memory interface card draws a fair bit of current even when the rest of the system is asleep. So the design has a field effect transistor in it. This is a 2N7000 field effect transistor. These transistors are quite common. You can buy a bag of 50 for about $3 or $4 from Amazon. There's a bag of them. And so that's it for the major parts. You probably need to buy wire. I buy this wiring kit in multicolors. This is from Amazon, and it's, I don't know, $15 or so for 6 rolls of wire. And one set of 6 rolls will probably build 2 or 3 dozen of these light cave intrusion detectors. So that's it for all the parts. Stay tuned for part 2, where I start describing and demonstrating how it all goes together.